In progress.
Hello, Matayom 1 or grade 7 students. Welcome to this class. Our topic is here on chapter 6 about heat. This will prepare you for the final test. Okay? So, well, today we study this chapter and I hope it will be easy for you. You can also find this in LMS, the Learning Management System. Right there, you just find it. If you find this, you will see that it's chapter 6. This is the plan that you see on screen. You can also watch this video on YouTube, okay? And there is more that you find about this one. And at the end of this lesson, I want you to take this chapter test to find out whether you would really be ready. But I want you to pass at least 25 over 30 average score, not the highest score. Even example, if you retake it, then get the average score. If you retake it, get the average score. But if you get the first test as 25 over 30, then you pass. Okay? Make sure your first test should have the highest score or very high score so that you will not keep on repeating the test just to upgrade or raise your average score. Okay? So take note, this is in your LMS. Now, our objectives today is here we need to define heat energy and understand expansion and explain thermal equilibrium. Thermal means heat. Equilibrium means balance. So heat balance. So today we will learn how heat moves and changes matter. What do you see in the picture? Of course, thermometer, and we have a source of energy in the form of lightning. Okay? So what is heat? All right? Heat is energy in joules. How is temperature measured? Anybody? Of course, temperature is measured in Celsius or degrees centigrade or degrees Celsius. In other words, heat is the energy, temperature is the measurement. How do molecules move? Do you know? Anybody? And so, I want you to watch this video on YouTube, how molecules move.
As the temperature inside the jar decreases, the water vapor molecules move more
Wait.
slowly.
I want to make sure that
And as the
you
temperature
heard it.
increases, the water vapor molecules move more
But
quickly.
what it's saying here is that as the temperature decreases, the molecules also are not moving fast. Oh, wait, I'll be back, son. I'll just want to make sure that you can hear it. Okay? Uh, so have you seen it? Now we know hot equals fast vibrate and cold equals slow vibrate. When we add heat, molecules dance faster. All right? Now, why can't a hot ball fit through the ring? Watch this video.
This is the ball and ring demonstration of thermal expansion. We have a metal ring and we have a metal sphere. At room temperature, the sphere easily passes through the ring. If we heat the metal sphere for a few minutes, the metal sphere expands. If we try to pass it back through the ring, it won't go through the ring.
You saw it, right? Yeah. Heat makes matter expand. get bigger. That's why the ball doesn't go through the ring anymore when it is heated. So cold makes matter contract, meaning it gets smaller. So repeat this vocabulary: expand, contract. Expand means get bigger. Contract means get smaller. And so here, I want you to see the real world out there with the Thai railway gaps. You see the gaps here? Why are there gaps in between and even right among or between the rails? Okay, we have some railway gaps. Why is that? I want you to watch this video again so you will see what it means. There's something wrong here.
How extreme heat can bend steel rails like noodles? Let's dive into the science behind track buckling. As temperatures soar, railway tracks absorb heat, causing them to expand. This process is called thermal expansion. When tracks can expand freely, they bend and buckle, creating dangerous conditions for trains. To avoid this, engineers use expansion joints, allowing tracks to shift safely. Thanks to science, we keep trains running smoothly. Stay tuned for more science shorts.
All right. Now, engineers leave gaps for expansion because when the heat comes, the trail expands. So the engineers are so wise. In Thailand, it is very hot. Without gaps, the tracks will bend. And what will happen to the train? They will be derailed, some will go over the railway, and there will be accident. That is not good if there are no gaps, all right? So what about heat flow? Now, question. Based on the rule and picture below, what is the direction of heat flow? Can you see it? Right? You see this hot coffee, and you see this cold hint. You see the arrow? Where is the direction? Is it from coffee to hint? Yeah, a better description is heat always flows from hot to cold. Okay? Heat moves until it finds a cold place. It will stop there because it is already cold. Now, when does heat flow stop? All right, I just said, but just look at this picture again. This is cold, this is hot. The heat flow stops where? Of course, in the center. Why? Heat flow stops when temperatures are equal because the center has an equal temperature between hot and cold. So the state is called thermal equilibrium or balance. Remember, I told you about thermal means heat, equilibrium means balance. So heat balance. So the center is called thermal equilibrium, where there is a balance between hot and cold. Now, what's the thermal energy in water video? I'll be showing you again. Observe the molecules in the ink or the watercolor. All right, here it is.
You may recall that all matter is made of tiny molecules that are constantly in motion, and the movement of these molecules is called thermal energy. Remember, the more thermal energy matter has, the faster its molecules move and the hotter it becomes. Look at how the motion of the particles change as ice melts into liquid water, then boils and evaporates into water vapor. Today, we're going to see this principle in action by observing how temperature affects the motion of molecules in water. We'll use food coloring as a visual tracker to reveal the invisible dance of water molecules at different temperatures. First, prepare 2 beakers that are each 3/4 full, one with very cold water and one with hot water. Now, here's the key moment. Drop 1 yellow and 1 blue food coloring drop into each beaker. When blue and yellow, which are primary colors, mix, they create green, a secondary color. Observe carefully and compare what happens in both beakers. Notice how the food coloring behaves differently in each beaker. In the hot water, the colors quickly swirl, spread, and blend into green. In the cold water, the movement is much slower and more gradual. Why? This dramatic difference reveals what's happening at the molecular level. The water molecules in the hot water are moving rapidly, constantly colliding with the food coloring molecules with greater force and frequency. These energetic collisions push the color throughout the water quickly. In contrast, the slower-moving molecules in the cold water bump into the food coloring less often and with less force, resulting in much slower diffusion. This experiment beautifully demonstrates that thermal energy truly is energy in motion.
Now that you have watched this thermal energy in motion, let us go back to this one again. All right. So question, why does the ink or the food color spread faster in the hot water? Okay, it was already explained that the water molecules move fast. That's why the ink or the food color or the watercolor spreads so fast, but it does not move fast when it is in cold water. All right, molecules move slow in cold water and molecules move fast in hot water. Here's the answer. Let me repeat. Molecules move faster. It means there is more energy. It means it is indeed an energy. In hot water, the atoms are dancing very fast, pushing the ink or the food color or the watercolor everywhere. Another question. What happens if we wait 30 minutes? Anybody can answer? Yeah. Remember the one I told you about equilibrium? Both cups reach thermal equilibrium or heat balance. Okay? They will eventually have the same temperature as the room. Now, when you heat a metal bolt, it gets what? Can you guess? Anybody can guess? Yeah. Is it smaller? Or is it larger? Or it expands? All right. If you understood the previous ones I talked about, you will see that, what is the answer? It expands. A cold hand touches a warm cup. Where does the heat go? Remember, the heat goes from cup to hand, of course, but honestly, it's from hot to cold. Heat flows from high temperature to low temperature. Now, for the summary of our study, heat is energy, and heat causes expansion. Heat flows until equal. Great job. You're now heat experts. For you to complete your lesson, I want you to scan the QR code here and then see if you can pass to prepare you for the final test. See you next time.